Imagine a signal from billions of light years away, lasting only a fraction of a second, but carrying more energy than our sun emits in days. These mysterious cosmic messages are called fast radio bursts, or FRBs, and they're among the greatest enigmas in modern astronomy. Every so often, telescopes on Earth pick up a powerful, millisecond-long burst of radio waves arriving from somewhere deep in the universe. The first one was only discovered in 2007. Since then, hundreds have been detected, but their true nature remains elusive. One way to get a sense of the enigma is through a poetic lens. In T.S. Eliot's The Waste Land, there's a passage that goes, "What are the roots that clutch? What branches grow out of this stony rubbish? Son of man, you cannot say or guess." The Waste Land, Part 1. The lines speak to a search for meaning in something inexplicably foreign, a feeling that resonates with scientists staring at FRB data, searching for roots and patterns in the cosmic static. So, what do we actually know about fast radio bursts? The facts are remarkable, yet sparse. First, EFRBs are real, physical astrophysical phenomena. They're not glitches in equipment or random noise. Each one reveals a telltale dispersion. Higher radio frequencies arrive before lower ones, a fingerprint of traveling across billions of light years, through clouds of intergalactic plasma. Second, most FRBs do not repeat. They flash once, then vanish from observation forever. However, a small fraction, called repeating FRBs, have been caught sending out bursts multiple times from the same location. This tantalizing discovery opens avenues for monitoring, but adds a layer of complexity to their origins. Let's pause for a moment with a reflection from philosopher Ludwig Wittgenstein. Whereof one cannot speak, thereof one must be silent. Tractatus Logico-Philosophicus, Modern 7. In other words, there are mysteries that remain just beyond the edges of our language and comprehension. This idea mirrors the way astronomers grapple with FRBs. We see the phenomenon, but the precise story behind it eludes us. What could possibly produce such a powerful and brief burst of energy? The suggested culprits are as dramatic as the bursts themselves. Some astronomers argue for cataclysmic events in distant galaxies, the collapse of a massive star into a black hole, the collision of two neutron stars, or even the merger of a black hole with a neutron star. Each of these events would be capable of unleashing colossal amounts of energy across the electromagnetic spectrum, including the radio band. Other theories focus on magnetars, a type of neutron star with a magnetic field 1 trillion times stronger than Earth's. Magnetars are already known for their sudden, catastrophic flares. If a magnetic field twists or breaks with enormous violence, the resulting shockwave could be enough to send out a detectable FRB. But the existence of repeating FRBs complicates things. Cataclysmic models make sense for a one-time flash. Multiple outbursts from the same object suggest some mechanisms are not entirely destructive. Magnetar activity seems a better fit for repeaters, but further observations are essential. Let's consider a stanza from Emily Dickinson's poetry. I dwell in possibility, a fairer house than prose. It's apt. When it comes to FRBs, the field is wide open for possibility. Each observation increases our sense of what might be true, but also underscores how much is left unknown. We're also forced to confront the sheer scale of what's out there. If each FRB is a flare from some dying star or colliding object in another galaxy, the universe must be full of violent, energetic events that we only notice when their light or radio waves finally reach us. The brevity and rarity of these events remind us just how much of the cosmos remains hidden, literally flashing past with only a millisecond's warning. Attempts have even been made to search for patterns in where FRBs appear on the sky. or whether they line up with known galaxies or other cosmic objects. While some have been localized to distant galaxies, there is no consistent characteristic. The host galaxies can be ordinary spiral systems, starburst regions, or almost featureless clouds. This diversity makes a simple answer unlikely. To step outside science for a moment, consider a passage from Carl Sagan's Pale Blue Dot. We are a way for the cosmos to know itself. FRBs challenge this. They suggest there are aspects of the universe that may forever remain just out of reach. Signals whose meaning, or even whose sender, will remain unknown while we search for patterns in their short-lived echoes. How do we even detect a fast radio burst? Telescopes like the Parkes Observatory in Australia, or the Canadian Hydrogen Intensity Mapping Experiment, or CHIME in Canada, monitor the sky and radio frequencies. They use enormous antenna arrays and sophisticated computing to distinguish true signals from a background of constant noise created by Earth's atmosphere, satellites, and other cosmic sources like pulsars. When an FRB happens, these systems spring into action, recording vast amounts of data in the span of milliseconds. Afterwards, analysts comb through terabytes of information, parsing out the special signature of an FRB, a sudden spike across multiple frequencies, arriving in a descending order due to dispersion. It's a needle in a haystack hunt, requiring supercomputing and lots of patience. So what about more speculative scenarios? If FRBs are neither catastrophic events nor ordinary magnetar flares, could they be produced by something entirely unknown? Perhaps even by artificial means. Some have playfully wondered if they might be beacons constructed by an advanced alien civilization, harnessing the energies of a star for interstellar communication. The idea is fun, but there's no evidence to support it. AFRBs look like natural phenomena, and all observed bursts have properties consistent with extreme physics in extreme places. Reflect for a moment on the words of the astronomer J.B.S. Haldane. The universe is not only queerer than we suppose, but queerer than we can suppose. The point is not that FRBs are necessarily manufactured or magical, but that we should expect the universe to continually surprise us. When our telescopes get better, they often reveal new mysteries, not fewer. Where might future research lead? As telescopes, like the Square Kilometer Array, come online, hundreds or thousands of FRBs may be caught each year. Scientists hope to trace their origins with pinpoint accuracy, mapping them back to their host galaxies and learning about the environments that foster such energetic events. By studying the way each FRB's signal is stretched, scattered, and delayed across cosmic distances, we can also use them as probes to study the invisible matter filling the space between galaxies. In that sense, every FRB is more than just a riddle. It's also a tool for mapping much larger, unseen structures in the cosmos. There's an old Japanese haiku about hearing a distant, unexplained sound at night. On the withered branch, a crow has alighted. Nightfall in autumn. Sometimes it's enough to let a mystery exist, haunting and incomplete, hoping that with time, patience, and better tools, its meaning might be revealed. In the story of FRBs, we hear a cosmic branch creak, see a brief flash, then nothing. The absence that follows is as important as the moment itself. Every detection adds another data point to the puzzle. Repeating FRBs might hold the key, offering rare chances to predict and prepare for their flashes, turning randomness into a timetable. Each subsequent observation helps to refine our models and points the way toward better answers. Why care about a split-second radio flash from the other side of the universe? Because in every unexplained phenomenon is a promise. A promise that our questions about energy, about life and death in the universe, about the boundaries of physics, can lead to discoveries we can't yet imagine. Fast radio bursts, with their power and brevity, challenge astronomers to rethink what's possible, pushing the limits of both observation and interpretation. Ultimately, FRBs remind us that the universe operates on scales of time, distance, energy, and mystery that dwarf human experience. They are cosmic punctuation marks, brief interruptions in the ongoing sentence of existence, compelling us to listen more closely to the static, to find out what else might be hiding between the words. So next time you look up at the night sky, think about the unseen events flashing and fading overhead, each one a possible FRB, a cosmic telegram arriving for an instant, its origins unknown, but its message certain. There is still so much out there that we do not understand, and that's exactly what makes the search worthwhile.